We all love a good fireworks show, so much so there are thousands of shows like this one across the UK every single year. Now there's a wealth of physics and chemistry behind fireworks, and we're going to show you some of these in today's programme. Some of the science is tricky to do in the classroom, but with the right advice and safety equipment, anything is possible. Today, with the help of a professional pyrotechnic team, we're going to show you our most explosive firework experiment. But don't try this at home. First up, how does a Catherine wheel work? So, Catherine wheels, here's an example here. How do they work? Well, it's a series of drivers, something that's going to create a force around a turning point. So we've got lots of rocket motors here around, and they're all going to fire to push the wheel around. So we've got a force around a pivot point. That creates our moment or turning movement. And so our wheel is going to spin around like that. So we'll see it get faster to start with, and then it reaches a point where it doesn't get any faster, and that's when our forces are balanced. They're a real crowd pleaser, but how do shells work? Now, our tubes here, our mortars are different sizes, and obviously you've got to get the right shell into the right tube, because that is not safe. Whereas if I drop it into a 75mm tube, that goes down nicely and is safe to fire. We've got our fuse here, which burns down, and at the bottom here, there's a bag of gunpowder, and that ignites, pushes the shell up with the expanding gases. So this gets fired out pretty much like a cannonball out of our mortar here. There's a delay fuse on the inside, and that delay fuse is timed so that when the shell gets to its highest point in its trajectory, the delay fuse is burnt through. Inside the shell, there's a burst charge. So the delay burns through, ignites the burst charge, and as that blows, it blows the shell to bits, and the stars around the outside get ignited in that explosion as well. And we see that as a colourful burst in the sky. Real crowd pleasers. So we'll load this one, and this is what it looks like. So what's the science behind this favourite? Now this is called a cake. Sadly, it's not the type you can eat, but it's a series of tubes that are fused together, and each tube has an individual firework in. The explosive charge bursts, those expanding gases force the effect out, and there's a little delay inside the effect. Now this one here is a much bigger one. This is a professional one. We're going to fire it electrically, and this has got 100 shots in it. They're much bigger, it's going to go higher with a lot more energy. And we've rigged it on a board here. It's attached to two wooden stakes here, and the stakes are on the side of the audience, so if anything untoward happens, the firework can move away from the audience. Let's have a look at a cake. Just how is this effect created? Now, a Roman candle is a single tube with a series of effects in it. Now, we've got stars layered on top of each other, and in between each one there is a lift charge and a delay. So the first lift charge burns, that goes bang, pushes the star up. Now, the star can be coated with a metal salt to give us a colour, so for example, barium chloride will give us a nice green colour. There's a compressed delay of black powder. That burns very slowly, and then it lights the next lift charge, that one fires out, and so down. So in this one we've got 7 shots. Now that's quite a slow pace. Sometimes we can have lots of Roman candles that are bundled together into a battery, a little bit like this one, but in the display that we've got set up here, we've actually got 12 tubes, they're bundled together, and each one's got 7 shots in it, so that's going to be very intense firing going off. And we've got them in a nice V shape here, so that gives us a nice display in the display. Final thing I'll point out, on the point of safety, is that our audience is that side, our fireworks are this side. So if they fall for any reason, though they are strapped on, they fall away from the audience, and that's very important to note.
reason I like fireworks is because the noises, the crackles, the lights, it's a good event to be at.
The colours, everything just lighting up the sky.
There were bangs earlier in lessons and we were all really excited and we wanted to know what was going on. So I think everybody looks forward to sort of a firework event.
How do fountains work? Now, fountains, that's something we're all familiar with. I have an example here. This one looks fairly harmless actually, but don't be fooled. It's got a metal powder mixed with an accelerant in there, so as it burns it's going to throw out a spray of sparks. Notice that the tube that it's in is fairly thick, so the energy can't come out sideways, and in the very bottom, if you're looking carefully, there's a very thick bung, so all of that energy is forced out at the top. Now this one here looks a bit more familiar. You can see these in the shop. But notice that the further down the fountain you get, the wider the base. So that's more composition burning per second. So our fountain gets bigger. So it starts really small and gets a lot bigger. What's the principle behind a rocket? Now, rockets, everybody knows rockets, and they always ask me whenever I'm firing a show, do we fire rockets? Well, we do, and I've got one here, so you can see the size of it. Now, it works on a principle a bit like the cone fountain, with all that energy being channeled through a tiny hole. Now, let me show you, the rocket motor is this bit here, and in the bottom, there's a metal section with a very tiny hole in. Now, Newton's third law tells us if we've got a force going that way, we're also going to create a force this way, and it's going to create thrust, and our rocket will go that way. Now, on top of the rocket motor, we've got this effects unit, and you can just hear the stars rattling around a little bit. There's a burst charge in there, so once the rocket burns through, our stars erupt. Now, the problem with a rocket, watch, if the wind's blowing this way, then as the rocket lifts, the wind will actually push the stick. And watch what's happening to the head of the rocket. It's actually going into the wind. So even if we have the wind away from the audience, our rocket is going to end up going towards the audience. And because it's going sideways, it's actually not going quite so high, so that's quite dangerous. So if there's a strong wind, we tend not to fire rockets because they don't go as high and they track into the wind. However, today's looking pretty good, so fingers crossed. I'm going to load it into our rocket rack there. That's how we fire them, and it's ready to go. What makes fireworks colourful? I'm going to show you these things here. They're called lances. They're a bit like candles, and we use them on displays for creating messages like good night, hello, good luck, that sort of thing. And you can see the different colours here. We've got yellow, silver, purple, right the way through. Now, the interesting thing here is it links to the colour chemistry of metal salts that you can do in the classroom. Now, the question for you is, which metal gives which colour? Let's have a look. We'll start with the yellow. That's sodium. That's white, that's magnesium. Purple, that's potassium. Red, that's strontium. The orange colour comes from iron. Green is barium. And that blue there, I'll leave for you to find out. So how do fuses work? Now, in the fireworks industry, we use fuses quite a lot. And these are professional materials, so it's not something that you can get your hands on in the classroom, but I've got some examples to show you here. Now, the first one is called raw match, and it's literally a type of string that's been soaked in a gunpowder slurry and then dried out. This one here is called piped match, and it's exactly the same as a raw match, except it's in a paper tube. And in this third one is an Italian fuse. This one's called Minetti, and it's literally black powder that's been compressed very tightly by a machine. So that's powder really, really tight together. Now, how is that going to affect the burn? We've got the open raw match, we've got the pipe match here, and we've got this pressed gunpowder delay. Let's find out. That's really nice because what you saw is it flashing over, so that's really quite unstable to use on site, because what you don't want is one firework going off and it's suddenly flashing over to another, so it's really not the best of fuses to use. Here we go. Now that's a fast burning fuse, and the reason it burns so quickly is because a flame front is contained within the paper and moves along, lighting more of the raw match ahead of it, so it burns really, really quickly, and we use that as an almost instantaneous fuse. Now that was burning very slowly, the reason being the powder's packed so tightly together, it's very difficult for the heat to get around the individual particles, and so it just burns through as if it's a solid burning material. So we use that as our, one of our delay fuses. It burns about 1 centimetre a second. Let's take a look at the famous gunpowder. Now whenever we talk about fireworks, we talk about black powder and gunpowder. This is the stuff here. It's potassium nitrate with carbon and sulphur. Now I'm just going to make a little pile here. So there are my materials. I've put a fuse in to make it safe, and we're going to light it and stand back and have a look at it. Expecting a bang? Well, watch this. So that's black powder, but there's another powder that we're using that's called flash powder. It's very different. It's a metal powder with an accelerant. Now I'm going to put a little bit in here so we can do a little test. OK, so that's in there. Again, we've got our fuse. And so this is flash powder now. It's very bright. That's why it's called flash powder. So we'll have a look. Let's see that again in slow motion. So that was flash powder, not terribly impressive, but you saw the bright flash, hence the name. Now this time we're going to contain the flash powder in a concussion cannon, and it's in this paper tube here, but we're actually going to drop the paper tube. I've already got one in here. That's going to prevent any of the energy going out sideways. It's all going to be directed up, and that rapid heating of the air is going to create a shock wave that you and I will hear as a sound wave. Now we're going to move back because the sound wave, in fact the bang that comes off this, is going to be extraordinarily loud. So let's move back. So now we've shown you all the explosive ingredients to a professional firework display. But remember, don't try any of these at home.
My favourite type of fireworks is the Catherine wheel because it's really colourful and it spins. They're really fun to watch and they make loud noises, which I like on the whole, so yeah, it's good.
Pretty amazing, actually. The colours, the bangs, everything, just spectacular.
I really enjoy the variety of colours and the heights. I thought it was lovely watching everything in the sky. It was brilliant.